Hello and welcome to the Unit 2 Section 4 video on special solutions for inequalities. So remember in the last unit we talked about special solutions for equations. Well, we have special solutions for inequalities as well. So here are the special solutions we have. Just like with equations, you can have some inequalities turn out to where the solutions are infinite, or we could have no solutions. So when we have an infinite solution set, it's when the variables cancel out and we have a true statement. No solution is when the variables cancel out and we have a false statement, just like with equations. So examples of what a true statement looks like: if you have something such as 4 is less than 8, 5 is less than or equal to 5, because they are equal, or 20 is greater than 1. Those would all be solutions that you would work out to, where your final answer would be infinite solutions. If you work it out and your variables go away and you end up with something such as 8 is less than 4, or 5 is less than 5, or say 1 is greater than or equal to 20, then these are all false statements and your answer would be no solution. So now that we've talked about that, let's take a look at what some of these look like with some examples. So in example 1, let's solve this. First, we have like terms that we need to combine. So we have negative 3 minus n is less than or equal to n minus 5 when we do 3 minus 8. So now let's add n to each side, and we get negative 3 is less than or equal to 2n minus 5. We can add 5 to each side, and we get 2 is less than or equal to 2n, and you divide each side by 2, and you end up with 1 is less than or equal to n. So in this case, we have one solution, which is 1 is less than or equal to n, and we know what to do with that. We have a closed dot at 1. Well, actually, our n's not on the right side, is it? We've got to flip it first, but we can still put our closed dot at 1, and it is going to go to the right. All right, for example 2, let's subtract 2x from each side. And when we do, we get 5 is less than 3. Well, we know that that is a false statement. Since it's a false statement, then we have no solution. And if we have no solution, we have no solution to graph. So therefore, you would do nothing with the number line. You would just leave it the way it is. Example 3, let's subtract r from each side. And when we do, we get negative 3 is less than 1. That is a true statement. Our variables went away and we end up with a true statement, which means we have infinite solutions. Now, when we have infinite solutions, we do graph on the number line, and your graph is going to look like this. You're going to fill from one side to the other. You're going to fill in the whole number line. So now you've seen what all three look like. Let's do a few more examples and see what we get. So for number 4, we've got something to distribute, so we'll do that first. We've got negative 16 minus 3r on this side. The negative 7 stays where it is for now. 3 times negative 7 gives us negative 21r. 3 times 3 gives us 9. Now we're going to combine the like terms. So we end up with negative 21r plus 2. And now we will move the r's. So let's add 21r to each side. When we do that, we get negative 16 plus 18r is greater than or equal to 2. Then we add 16 to each side, and we get 18r is greater than or equal to 18. And when we divide by 18 on both sides, we get r is greater than or equal to 1. So this one is one solution. And our one solution is r is greater than or equal to 1. So since we're greater than or equal to, we are going to fill in the 1, and we are going to shade to the right. For number 5, we are going to distribute first. So we get negative 3k plus 3 is greater than negative 15 plus 6k. Let's add 3k to each side. And that gives us 3 is greater than negative 15 plus 9k. Let's add 15 to each side. And that gives us 18 is greater than 9k. Divide by 9, and you get 2 is greater than k, but we have to flip the whole thing, so k is less than 2. So we have an open dot at 2, and we are going to shade to the left. And in this case, we do have just one solution. For number 6, we have to distribute first. 6x minus 30 is less than negative 32 plus 6x. And we're going to subtract 6x from each side. And that's going to give us negative 30 is less than negative 32. This is a false statement because negative 32 is actually less than negative 30. So that means we have no solution, and we will not fill in anything on our graph. For number 7 here, let's combine like terms first. So we have x plus 5 is greater than or equal to negative 3x plus 3x gives us 0. And now we'll just subtract 5 from each side. So we have x is greater than or equal to negative 5. So our one solution, we're going to fill in the dot at negative 5, and we are going to shade to the right. All right, let's take a look at what's going on with number 8. First, we're going to distribute, so we will not touch the left-hand side. So we have negative 4n plus 16. Then when we distribute the next one, we get negative 4 plus 12n. And now we're going to combine like terms. Starting on the left, we've got a 7n and a 1n, so that's 8n. We have negative 6 plus 1, which gives us minus 5. Is less than or equal to, we got 12 minus 4n, so that's going to be an 8n. And then 16 minus 4, that's going to give us 12. And then if we subtract 8n from each side, let's make that a little cleaner. Subtract 8n from each side, we get negative 5 is less than or equal to 12. That is a true statement, so we have infinite solutions. And since we have infinite solutions, we are going to shade along the number line in both directions. All right, for number 9, we are going to distribute. We'll distribute on both sides. So we have negative 30, negative 6 times 5n, that's going to give us negative 30n. It's greater than negative 30, and then we have a negative 30n. So if we add 30n to each side, this will make our variable go away. We have negative 30 is greater than negative 30. Well, we know that's false because they're equal. One's not greater than the other. So since it's false, we have no solution, and therefore we will not be shading anything in on our number line. And then for number 10, let's combine our like terms on the right-hand side. So 1 plus 1 is 2, minus 4 gives us negative 2. So we have negative 4n minus 2. Let's add 4n to each side. So we have our n on this side to begin out with. So we get 6 minus 4n is less than negative 2. Subtract the 6 from each side, and we get negative 4n is less than negative 8. Divide by negative 4. Remember, you have to flip the sign because we divided by a negative, and we get n is greater than 2. So we're going to do an open dot at 2, and since we are greater than, we are going to shade to the right. Now, before we wrap up this section, let's look at some examples here. If we're given the value and is in a solution set, let's determine if that value is indeed in the solution set for the inequality. So we'll do that by plugging the value we're given into the inequality and see if we get a true or false statement. So for this first one, we're going to plug in 4 for n, and then we're going to evaluate both sides of the inequality. So 4 plus 8 gives us 12, and 12 is indeed less than or equal to 13. It is less than, so it's true. So therefore, 4 is in the solution set. For this one, we're going to plug in negative 5 for h. Negative 5 times 5 gives us negative 25. Negative 25 is not greater than negative 15. So, since this is false, negative 5 is not in the solution set. For this one, we are going to plug in negative 9 for s. Now remember, when we multiply by a fraction, this is multiplying across. So we have negative 18. Well, actually, negative times a negative gives us a positive, so we just have 18 over 3. It's greater than or equal to s. And 18 divided by 3 gives us 6. It's greater than or equal to 6. This is true. So yes, negative 9 is part of the solution set. For this one, 4 times 3 is less than 3 plus 8. Well, 12 is what we get on this side. 8 plus 3, that's going to give us 11. 11 is not greater than 12, or 12 is not less than 11, so this is false, which means it is not part of the solution set. For the next one, we have 7 minus 2 times negative 1 is greater than 3 times negative 1 plus 13. Again, I'm just plugging in the number for the variable. So 7 plus 2 is greater than negative 3 plus 13. So 7 plus 2 is 9. Negative 3 plus 13 is 10. 9 is not greater than 10, so this is false. So this is not part of the solution. And then 3/4 times negative 4 minus 2 is less than or equal to 2 times negative 4 plus 8. Well, 3/4 times negative 4 gives us negative 3. On this side, we have negative 8 plus 8. Negative 3 minus 2 gives us negative 5, which is less than or equal to 0. This is true, so this is part of the solution set. So now you see what some special solutions look like. Now you can see if you can determine if a solution that you're given is actually part of the solution. Now in the next section, to close out the unit, we will go into some word problems and apply what we've learned in this unit into real-world situations.